to the next video in the systems programming series. We're still talking about chapter 2 of Dive into Systems, the textbook, moving on to section 6 on strings. So as we, I believe, have talked about already, C does not have a dedicated string type. Rather, strings are merely arrays of chars, and specifically those that are terminated by the null char. So we can see a quick review here. We have the string library, string.h. You import it like this. You can statically declare char arrays here with capacity 10, and we fill a few coordinates with chars. We terminate it with the null char, and that makes it a string. And then we can use the string library and do various things. I think this is all review. We can, because we can dynamically allocate arrays and strings are char arrays, then, sort of the upshot, I think, is pretty straightforward. You can initially set your pointer, right? So this dynamic char array initially looks like the declaration of just a pointer to a char. We can initialize it to null. Here we just copy the static char. We use the library to observe its length. And then here we malloc the new str that is being dynamically allocated so that, basically this gets treated as an array so that, we no longer would even be tempted to think of this as merely a pointer to a char. Because of this malloc, we are now treating it as an array of size plus 1. The size comes from the earlier declared string, so we're giving it the number of chars needed for the text hello, which is size, which is 5. But then we give it plus 1 because we need that null char terminator. We check for null, standard thing, and then we can basically use this dynamically allocated char array in the usual ways that you would use any string. Don't forget to free it up and null the pointer at the end, and finally return 0. It is worth noticing that strcpy and strcat are sometimes dangerous to use because they really depend on finding that null terminator, and if for whatever reason that somehow, without the programmer's knowledge, got sort of neglected, then things can go very wrong. So they are somewhat risky things to use. So I guess here we're going to see a few more library functions, like I guess strlen, although I think that was up above. Strcpy, I think that was up above. Oh, by the way, notice that strcpy, what does it return? A char star, which is, I think, fairly sensible. Now, I guess, it doesn't have to return anything because sort of the point of its use is to take the source char and put it into the destination char array. So, just with that functionality alone, you wouldn't necessarily need to return anything, but it does return the address of the destination string so that, in a sense, in effect, that is returning the destination string. You can use strncpy and further specify a size so that, if you have, some good reason for why you would want to terminate the copying at some size, like you want some kind of safeguard, like, possibly you specify sort of the minimum between the size of the source and the destination, then you can kind of guarantee that this call to copy will never go beyond the bounds of any of the char arrays within sight. And so that can be sort of a safety procedure. So down here we can see an example of its use. It looks like strncpy does not necessarily add the null terminator. So when using strncpy, you have to explicitly separately put the null terminator where it's supposed to go. Then we have strcomp and strncomp. So this is for the comparison of strings. If you merely tested the equality of strings, because these are fundamentally, basically pointers to an address for the base address of the array, then when you're testing this equality, it's going to test for the equality of the addresses, so that in a sense it is physically testing for the two strings to be the exact same string, so that if you had, like, for instance, the string ABC on one side and another string ABC on the other side, it will return false, because those are two different copies located in two different places in memory. And since they don't share the same address, it's going to, right, even though the characters are all, equal in value, it will not say that they are equal, because it's checking for the address in memory, the physical address, rather than something like equivalence. It is checking for physical equality. So how do you get around that? You use the strcmp, which returns some coded integer responses. If they are character by character equivalent, it returns 0. If the first one is lexicographically earlier than the second one, then it will return a negative number, I think -1, but really you shouldn't even bother yourself with exactly which negative value it returns. Just know that it returns some negative value if the first one is smaller than the second one, and returns a positive number if the first one is bigger. So you use these coded values to decide which one is earlier than the other one in lexicographic order. And strncomp is presumably very similar. You can specify a number of characters to go out to in the comparison, and never use more than this many characters in either of the strings. Okay, strcat is a concatenation function. I'm going to move quickly now because, I think, it's pretty easy to read up on these things. So strcat is for concatenating two strings, putting the source string at the end of the destination string. Str gets you a substring. Locate a character C that is in the passed in string. Right, so I think you specify the char, the string, basically, which is a pointer to a char, and an integer. The const part right here indicates that the string is never manipulated in the run of this function. Same thing, up here and so on. Which, by the way, notice is not true up here, because the destination is manipulated, because we are taking the source and putting it onto the end of the destination, so the destination is manipulated. And these are dangerous, by the way, as well. You do have to make sure that the destination array has space enough to further accommodate the source string. But getting back to strchar, you specify a string and an integer code of a char. I'm not sure why we don't just declare this as a char C, but so this is actually a char C. It is presumably, you could also regard it as an int, because chars are basically ints. But so you specify this value C, and it finds the index of the first occurrence of that char. Strtalk is to get string tokens, so that basically if your string is delimited, right, that basically there are these just imagine that you've got 1, 3, -2, 7. And so you could think of this as comma separated values, right? So these are comma delimited, and if you get the tokens using the delimiter comma, then this would basically turn it into an array of strings. I'm not writing it in true code, but just in kind of a diagrammatic code, that you would get the array containing the string 1, 3, -2, and 7. So that's how, right, it basically just breaks up a string at its delimiters. This is very similar, if not exactly the same, as the Python, split function. Then there's sprintf, which is kind of nice. So we know that printf will print to the console a format string. But what if you didn't want to print it to the console? What if you simply wanted to take a format string, do whatever you write, it's got numbers, it's got strings, it's got floats or whatever. They all go into the appropriate places. But you don't want to print that to the console necessarily. You just want to build the string, so that you want all of the results of those substitutions to go into some variable holding a string. Well, that's what sprintf is for. So that's a string print format function. So for instance, let's see its use. You've got some values like a char, a float, an int. You use, so this is your destination string, so to speak. So you call sprintf, you give it the string that where everything is supposed to go. You give it a format string. You give it something to go in place of %fs. That is going to be the string Henry. You're going to give something to go in place of %d, that's 12. You're going to give it something to go in place of the next %d, which is 7. And so what this does is, takes all of this and puts into the destination str the string. Does it say it here? Well, I guess it doesn't show you the result, but it will be Henry is 12 years old and in grade 7. The standard library contains a number of functions for manipulating char values. So here you have a test for is lower, so that should return 0 if it is not lowercase, right, a lowercase char, and 1 or a non-zero value if it is a lowercase char. And likewise with many of these other examples, I think we'll just skip right over that. And it is also possible to convert strings to other types, right? So I guess this is converting a string to an integer. And I believe what we are really saying here, right, yeah, is that if you give a string, which, right, the string clearly is meant to represent 1, 2, 3, 4, or 1,234. So that's like the intention, but as far as the computer knows, it's just a string, not a number. So what if you want that number? This function atoi, which comes from the standard library, allows you to input the string 1, 2, 3, 4, and it returns the integer 1,234. And likewise for floats.